So far, we've only been staring at numbers within the MATLAB interface. However, that doesn't make too much sense. As humans, we can hardly interpret these numbers in detail, especially if they are quite high dimensional. And in order to have meaningful discussions or draw meaningful conclusions about the data, the numerical data that we obtain from our numerical models and numerical experiments, we need to be able to convey the message of this numerical data in a clear and intuitive way. And that will be done with visualization of these numerical data, which is the topic of the current video. So in this example, we're going to plot the sine function within a range from 0 to 2 pi. So 0 to 2 pi for x, and we want to plot the value of the sine function of x. Now, in order to do this, we first need to create the numerical data that we want to visualize. So first we create the vector x, ranging from 0 to 2 pi. And for this I will use the linspace function, which we've seen before. So this starts from x is equal to 0, goes all the way to x is equal to 2 times pi. And let's say we use 1000 entries in this vector x. We want to calculate now the sine of x, so the sine function of x. And we've already seen the sine function, so let's take a look at it, how we would use this. And we've seen the sine function before when we wanted to calculate the sine function of a single number. For instance, the sine of 0 is equal to 0. Now, in contrast to this previous case where we had a single number, now we want to calculate the sine of 1000 values, which are all in this vector x. Fortunately, we do not have to do this manually for every element, and MATLAB allows us to simply give as an argument the full vector x, such that every element in the vector, in the output vector y, will have as an entry the sine of a corresponding element in x. So we see here now that the vector y is created, and y has values which go from 0 and then increase up until a value of around 1, decreases and goes back up until something very close to 0 again. So this is very small. This is times 10 to the power minus 16, goes very close to 0 again at the end. So this kind of, at least intuitively, looks like a sine wave if you look at the numerical data, but to be sure, we really have to draw this function, this numerical data that we just generated. And in order to do that, we will use the plot command. So let's first take a look at the documentation for the plot command. And we see that there's already quite some elaborate documentation of the plot command. The idea of the plot command is that it plots a vector y versus a vector x, which is exactly what we want to do here. We want to plot this vector versus this vector over here. So let's just give it a go. So I will write plot the vector x and y, and in response MATLAB will open a figure window such that we see over here, where we have a two-dimensional plot. So we have a horizontal axis on which the values of x will be set out, so ranging from 0 to 2 pi. And we have a y-axis on which the values of y will be drawn, and that is actually the sine of x, so we have indeed a nice sine wave. Now, obviously it's important that if you make some kind of visualization, you clearly indicate on the plot what you are actually plotting. And for that we can decorate this plot using simple commands. We can add a label to the horizontal axis. Let's say that we want on the horizontal axis indicate that this is the x, and on the vertical axis we want to say that this is the sine of x. So we see that this has been added to the plot over here as well. Now finally, let's say that we want a title for our figure. This is the graph of sine of x. And we see that this has nicely been added to our figure as well here. So these are the basics with how to produce simple line plots of two vectors versus each other. Now, if you go to the MATLAB references, the MATLAB documentation online, you will find that there is a very rich library of visualizations possible. So if we plot here on, if we click here on graphics, we see quite a detailed library of things you can do, plots you can make of your numerical data, and it all depends on what you're really trying to look at. Those are not being discussed here within this video, but it's good to have an idea on what's available for your future endeavors in scientific computing.